ポイントをビットコインに変えることができます。楽天市場やお店で貯まった楽天ポイントを使って初めての人でも簡単にビットコインへ交換できるんです。早速アプリをダウンロードして取引開始。ポイントは運用する時代です。
突然ですが、ビットコインの支払いに必要な時間は X ポスならわずか数秒。世界のお店に広がる X ポス。他の通貨も使えます。さあ始めましょう。詳しくは Amazon またはウェブで検索。
ブロックチェーンというのは非常に大きな役割を担うんじゃないかと思っています。でそれによってやっぱり社会が変わっていくっていう実感がありますから、それを何としてでもやり遂げたいと思う。でこれを本当に実現して世の中を変えて便利にしてみんなが幸せになる顔が見たいと思っています。
I'm a professor at Cornell University. I'm also the CEO of Avalanche, which is the company behind Avalanche, the protocol. Today, I want to talk to you about Open and Programmable Finance with Avalanche. In short, we built something amazing and very different from all of the blockchains that you're familiar with. And I want to explain to you how it's different and what makes it different. But before I do that, let's talk a little bit about where we are today and where the blockchain world stands. Blockchains are now almost a household word now. Everybody has heard of them. Everybody knows that they represent an enormous opportunity and a complete rethinking of the financial system. The market cap of the coins we have about 6,000 coins, and their total market cap exceeds $300 billion. The amount of VC investment, venture capital, that has gone into blockchains exceeds $20 billion. And more importantly, about $20 billion of hard-earned money from people like you and me has been invested into this community by regular people like us. Even Facebook is looking to issue a cryptocurrency. So are many central banks. I have actually spoken to the Bank of Japan back in the day, a couple of years ago. I have spoken to just about every big major central bank about blockchains and how to issue central bank backed digital currencies. The era of digital assets is just starting, and that's our core belief. Now, as I mentioned, there have been 6,000 coins. All of these coins are trying to essentially duplicate the same vision. And that same vision, that one vision, comes from the one person in this space who really did have a unique vision, and his name is Satoshi Nakamoto. Everybody else is copying what Bitcoin is trying to do. Everybody else is trying to come up with an alternative to fiat currencies. Everybody else is therefore moving very fast towards undifferentiated products. All of the coins are copies of each other, in short. And we saw an explosion of coins in the 2017 and 18 timeframe. Many of these products failed. Most of these products were terminal. They're not enablers for building new exciting things on top. All of them are speculative assets trying to do pretty much the same thing. So that is one of the main things we're going to be fixing in Avalanche. We are not trying to be money. We are not trying to compete with Bitcoin. We are not trying to compete with Ethereum. We have a unique vision different from them, and we have a unique technology different from them. And this unique vision, which I'm about to explain to you, and this unique technology comes at an unprecedented time. Many national economies, even as I speak to you, in the West have shut down. Astronomical amounts of debt are being created. Many weak companies, banks, and some national economies will collapse. And the flight to unseizable assets is already taking place. This will only get faster in the months ahead. I see an enormous boom in the crypto space coming up ahead. And yet, for us to branch out of speculative territory into new financial products, into reimagining finance, we really have to handle three big problems ahead of us. What are the three big problems in front of blockchains, you might ask? Well, the very first one is scale. First generation platforms that we're familiar with simply cannot support trades of digital assets at global scale. These platforms that exist today can barely handle about 3 transactions per second, 7 transactions per second, or 15 transactions per second in a pinch. And as the numbers go up, they necessarily trade off decentralization. The one thing that makes these platforms valuable goes out the door as people try to squeeze more performance out of them. And the scalability problem is enormous. If you try to be money, you have to scale. If you try to handle, for example, the payments at a small country like Venezuela, you cannot do it with Bitcoin as it is today. You have to go to layer 2 solutions. You have to go to more complicated solutions, which to date have not seen any traction whatsoever. So I'm going to show you how we handle the scale problem in a second. The second problem is usability and flexibility. All of these networks offer the same service. They are undifferentiated. They're trying to do the same thing. And there is a bigger universe out there. And I want to give you a glimpse of all of these exciting assets that are not money that we are going after in the Avalanche system. We want to digitize every single valuable thing and put it on a blockchain. This includes commodities. It includes oil, wheat. It includes every single kind of plant and animal product. It includes every single kind of virtual thing like financial products, bonds, derivatives, options, futures, credit default swaps, and so on. Also, it includes real estate, fractionalized real estate, income sharing agreements, and the like, all the way down to NFTs and game assets. We want to go after these things. And to reach this, you need to provide a platform that is far more flexible than the ones that you're familiar with. And I'll show you how we do that. And the final thing that I want to impress upon you is the need for governance. We all know how hard it is to plan financially for, let's say, the year ahead. We're all familiar with countries that used to have 5-year plans. And we know how miserable it was when the USSR was having their 5-year plans. Every 4th year, they found themselves completely out of sorts and had to replan. Now imagine trying to plan for eternity. It is simply not possible. These blockchain platforms that we build have to be flexible enough to evolve with the changing needs of users and with the changing macroeconomic climate. So these 3 problems exist, and they are pervasive. All first generation coins suffer from them. And I want to show you a new vision that's a complete big breakthrough that addresses all three of these challenges. Now, as I said, I'm a professor, and my area of expertise is distributed systems. This area has been around for 45 years. It got started in the 70s, and these 2 people on the very left-hand side, Professor Barbara Liskov and Dr. Leslie Lamport, are heroes of mine. They have been recognized with the Turing Award, each independently, and they came up with classical protocols. These are protocols that are based on voting. And these protocols are very well established. There are hundreds of them in the academic literature. And we knew all about them. They're making a resurgence even as I speak. ETH2O is one of these classical protocols. EOS is one of these, NEM is one of these, NEO is one of these, and there are many other proof-of-stake protocols using these classical protocols. Now, these protocols existed when Satoshi Nakamoto came along. And Satoshi Nakamoto, even back then, as we can see today, could look at these protocols, and he did, and he wrote very explicitly that these protocols are unsuitable for open financial systems. They are fragile. They are closed. They require knowledge of all participants, and they lead to closed systems. They lead to cabals controlled by a small number of players. That's why Nakamoto himself invented his consensus protocol in 2009. And that's a big, big breakthrough. He does not have a Turing Award, but he has instead 1 million Bitcoins. Now, something big happened about 2 years ago that you may or may not have heard of. An anonymous group calling themselves Team Rocket came up with a protocol called Avalanche in 2018. And that protocol is just as groundbreaking as Nakamoto's, as the work of from the 70s on classical protocols. It's a completely new way of building consensus protocols that addresses the weaknesses of both classical and Nakamoto consensus. Now, I want to come back to what that means. Now, what is wrong with Nakamoto consensus? Well, first of all, it has very long confirmation times. When you make a payment with Bitcoin, it takes about 1 hour for that payment to become finalized. The throughput is very, very low. The throughput is on the order of about 5 transactions per second. And 5 transactions per second is about the speed of a big department store in Japan. So you're not going to be able to take over Wall Street, which I can see from my window here, at those speeds. You need many, many more zeros next to that number 5 if you want to tackle something as big as that. And worse, these systems are centralized. Bitcoin is a centralized system. It is controlled by a small number of mining pools. On the order of about 19 mining pools create 99.9% of the hash power in Bitcoin. These are actually, they're better than having a smaller, more, even less decentralized system. But nevertheless, they're not really all that decentralized. And finally, they consume a lot of energy. And you may not care, some people might not care about the energy we put into the planet, we burn and warm up the planet with, the problems we face for the environment. But most people would care about the leak of value from the store of value. The money is going to the power companies. It's not being used properly. Now, of course, this is the reason why you're seeing a number of recent protocols, recent project groups that don't have anything innovative. They go back to the 90s. They resurrect one of the classical protocols. They put some blockchain makeup on it, and they try to serve it up as a new coin. So Cosmos, Polkadot, etc. These are all protocols from 1999. These are all based on older protocols. They cannot scale beyond a few hundred validators. The best classical protocol was designed by Ted Yin and friends. Ted Yin is a graduate student. He's a student of mine at Cornell University. He did it over the summer. He came back and said, I did that. And I now want to work on something truly innovative. And he's currently working on Avalanche. Now that protocol is called Hot Stuff. It is the basis of Facebook's Libra currency. So that's the best. We are the ones who did it. And we are the ones who are not using it because we don't think it's good enough. These systems are so small, they lead to cabals and lack of decentralization. They are centralized currencies at their heart. And they're not robust, and they're fragile. So what makes Avalanche different? At the very core of Avalanche lies an entirely new approach to how to achieve consensus. This is a leaderless protocol. It's a leaderless protocol that is based on metastability. It creates an environment in a distributed system where the nodes are unhappy, so to speak. They're in a high energy state as long as there is no decision. And they become happy and harder to change as they find more and more support for their decisions. And when the network has actually come to a full decision, it's at an immovable low energy state. Think of it as a spinning plate, and at some point when it falls to the ground and is lying on the ground, it has made a decision. That's when it's happiest. It's much harder to take it from that state and back to go spinning in the air again. Now, this algorithm is quiescent, it's green, it's sustainable, and it scales incredibly well with increasing numbers of nodes. It can accommodate tens of thousands to millions of participants. This is not something anybody else can say. They all compromise decentralization. This protocol approach does the exact opposite. It has some amazing features. One of the main features is robust like Nakamoto. It's robust like Bitcoin, but it's very quick like classical protocols. It makes a decision in under a second. It achieves high throughput. I'm going to show you numbers later on, but it's 3 times faster than Visa. I never thought I'd see this in my lifetime, but we were the ones. I'm really proud of this as a professional accomplishment. We were the ones that built the system that is faster than Visa, even though it is decentralized, spread around the globe. It's lightweight. It consumes very little energy. There is no mining. And very interestingly, it can withstand adversaries larger than 51%. So somebody with even 60% of the stake in the system is unable to revert the safety of the system. Sure, they can maybe impact liveness, but they cannot impact safety. And it's highly scalable. It scales like no other protocol family on Earth. So I mentioned how it achieves, the kinds of performance it achieves. It does this by following a protocol format where every node talks to a very small subset of other nodes. So every node polls a small number of nodes, then it changes its decision, and the analysis and math works out such that in a very small number of rounds, everybody comes to make the same decision. So if you were to use a classical protocol with 10,000 validators, you would end up having to send about 100 million messages. If you use Avalanche, you end up sending about 85 messages. So that's why this protocol is so much more efficient. That's why it could actually feasibly run on a telephone, on a cell phone. The latencies it achieves are enormously faster than everything else. Bitcoin is 3,600 seconds here. That's about an hour. Ethereum, for approximately equivalent security, is about 518 seconds. Algorand, it's one of the newer coins by a very well-esteemed colleague of mine from MIT, requires 50 seconds. We require less than 1 second. We always advertise 1 second, but in reality, in our current mainnet, we went live only 3 weeks ago, but in our current mainnet, we're achieving finality in under 200 milliseconds. The throughputs are also enormously high. I mentioned that we're 3 times faster than Visa. So Visa gets about 1,700 transactions per second. We get 7,100 transactions per second. It's much, much faster than Visa. At the same time, we accomplish this not by centralizing the system, but by doing the exact opposite, by decentralizing to potentially millions of participants. Now compare Bitcoin's 19 mining pools. Ethereum's, like it used to be 11, it's a little larger now. Ethereum has a few dozen mining pools. EOS has 21 block producers. We can accommodate millions. Our current mainnet has 600 validators. You and I can meaningfully participate in the system. You do not need anything more than a Raspberry Pi. In fact, some people participate in the system with actual Raspberry Pis. The Byzantine tolerance threshold is configurable, and the system degrades gracefully if there is a really large attacker with systems like Cosmos or Polkadot. As soon as the attacker is larger than 33%, he can take over the system. This is not so for Avalanche. I'm not going to be able to have time today to go into the details why, but it's a fascinating property of the way these metastable protocols are designed and operate. Now, that's just the core protocol, and it's a big breakthrough given to us by Team Rocket. On top of this, we brought some additional insights that completely re-envision how blockchains work. Now, one of the main things we do is provide extraordinary flexibility. Now, all of these first-generation platforms you might be familiar with do pretty much the same thing. Everybody copied it from Satoshi, and Satoshi was the first person with the simplest possible vision. Now, what is that vision? There's a coin, there's a virtual machine that implements the coin, and there's a network that runs the virtual machine. That's what we have today, and everybody else copies it because it's a nice design. Now, this design cannot integrate into existing legal systems. It's extra legal. It's outside our legal system. It enforces only its own rules and cannot be made to merge with any other rules underneath. This creates a poor foundation for issuing digital assets. If you talk to enterprises, what they want to do first and foremost is create new digital assets. They want the blockchain goodness, but they typically want a specific VM custom tailored to their needs. And more importantly than that, they want to be able to control the network so that they can enforce unforeseen changes on their assets and control the full life cycle of their assets. So what does this mean for us? Well, we have AVAX, the coin, we have our own Avalanche virtual machine, and we have our own network. But we envision a world where anybody can create many other coins on top. And as they create those coins, they also specify their virtual machines, and they can create sub-networks. So somebody in Europe, a company in Europe, can issue, let's say, bonds and say something like, we're going to issue these bonds. This is how they behave. And by the way, they have to be deployed on a sub-network that is bound by the rules of the GDPR. Or someone can say, look, I'm going to create a fractionalized real estate token. It has its own behavior and it's subject, it runs on this other sub-network that is bound by this particular agreement. Every one of the nodes in this network is bound by these additional rules. And therefore, there's a legal foundation to everything that happens on this blockchain. Now, to techies, this might seem like a small thing. And remember, like there are small differences here that seem that, to the uninitiated, they seem small, but they have lots of consequences. Turing completeness, we all realize, gave people control over the virtual machine. Well, control over the network is as big a step as Turing completeness in the virtual machine. It means that you can control what happens inside the subnetwork. This makes Avalanche a network of networks. It supports many different kinds of coins, each with their own behavior and each with their own set of nodes that support that coin. Avalanche makes it really easy to create arbitrary tokens and to trade them. It enables many scripting languages, and one can then incorporate different rules for real estate versus gold versus diamonds versus whatever else. And many different platforms can coexist. So you can do atomic swaps of real estate for diamonds and so on and so forth, because all of the nodes share the same protocol structure, although they might differ in the rules of their virtual machines and in the rules required to govern their networks. Avalanche stakers know what they're actually supporting. It is completely unlike Ethereum. In Ethereum, the miners don't know what they're doing. They're just executing code. Some of those codes have to do with games, and some of those codes have to do with creating new assets and new value. To the miners, they appear the same. They cannot extract value from them. In Avalanche, every asset is a first-class citizen. The stakers know what kind of assets they're supporting. They can provide asset-specific services and extract value commensurate with the services they provide. And finally, the Avalanche operation, the protocol itself, lends itself to natural governance. The stakeholders themselves, the people who hold AVAX tokens, can change key parameters in the system. This is completely in opposition to how people build first-generation coins. In first-generation coins, everything is baked in, and Satoshi baked in the issuance curve for the coins for all time. And sometimes he got it right, sometimes he overmints, sometimes he undermints. And other people who copied him are making even bigger mistakes. For example, look at Zcash today. Zcash is minting far too many coins. Ethereum is minting far too many coins, and yet they're unable to change these things. In Avalanche, key economic parameters are subject to change. You and I and everybody all together, we implement the central bank, and we're able to change the key parameters that govern the system. Things like the minimum staking amount, minimum staking period, the minting rate, these are all subject to change. Now, I should mention that AVAX is actually a hard-capped coin. So the number of AVAXs that can ever be issued is definitely fixed. but the rate at which we approach that number can be changed. If today we need to offer a large interest rate to attract stakers, then we can do so. Then we in fact, that's exactly what the system is doing even as we speak. We expect that very shortly we're going to find that that the users might want to say, hey, let's not mint as much. Let's boost the price instead by lowering the minting rate. And this is something that the Avalanche system can do and boost the price as a result. This allows us to build a crowd oracle for economic decisions that takes the place of a central bank. So we are the central bank and we control what happens in this network. So that leaves us with a very interesting situation. We recently had a very successful public sale of our token, and very shortly afterwards, and we take pride in how fast our team is in building our infrastructure. Very, very shortly afterwards, we went mainnet. We have a live mainnet even as we speak, but we're in our very early stages. We've only been live for about 3 weeks. We're already listed on Huobi and Binance. And we're very, very proud of our situation right now. We not only support the Avalanche virtual machine, we also support the entirety of the Ethereum virtual machine. We're a smart contract platform. We support DeFi. Every single contract that runs on Ethereum also runs on our platform. Just to give you some bit of perspective, the internet was introduced in 1962. It underwent many cycles, many cycles of growth and change. And the internet today looks nothing like the internet in 1962. It looks nothing like the internet of 2000. I was around in 2000. I was around in 1989 as well, the very first time when I met the internet. 1986 is actually when I first met something like the internet, BitNet, the very first, one of the precursors. So these systems evolve. The names might stay the same, but they have changed drastically. Crypto is no different. It is not going to be the case that the first solution is the ultimate solution. To the contrary, the ultimate solution has to constantly change and shift. Blockchains represent a natural evolution of money from archaic fiat-based models to internet-based value creation, transfer, and storage. But those things cannot happen naturally and easily unless the 3 big challenges are met. One of the key of the challenges is scale and performance. I did not have time to go into it, but the way the protocol works is unprecedented. It is literally the 3rd biggest breakthrough in the space of consensus protocols. Over the entire history of the scale. Second big breakthrough is it's usable and interoperable. It's flexible. It can accommodate many different coins. It is not a system for just one coin. I am not here to say, hey, buy AVAX, hold it, and speculate on it. To the contrary, do whatever you want with AVAX. You don't have to buy it even. But if you want to create your own coin, this system is the one that you want to use because it's so flexible. And it allows interoperability between different people. It allows anybody who's wishing to be compliant with regulations to actually be compliant with regulations. And finally, it's a flexible platform that supports governance. So we do not have to bake into the system all of the decisions forever after. On day 0, we don't have to make our minds and get stuck for years and years and years on end. We can change the key parameters on the fly as the economic conditions change. Crypto, I believe, is an extinction level event. So even as I sit here in New York City and look out towards Wall Street, I can see a whole lot of companies that bring a very small amount of value, and yet they make enormous sums of money because they have cornered certain markets. And what I also see are a bunch of companies that are failing to innovate and failing to work for the common person. And blockchains allow us to completely upend, completely reimagine that world. But to do so, they need to solve these three problems of scale, usability, and flexibility. And what I think I did today was give you a glimpse, just merely a glimpse of the Avalanche approach to handling these three challenges. We are fundamentally different from every single one of the 6,000 coins that came before us. We are the fastest moving team. We are the most innovative team. We are the team that other people copy from. And we have been that team for many years on end. So I'm going to stop at that point. Thank you very much for listening. Thank you very much for your time. And if you have questions, I'll be very, very happy to take them.